Welcome back, 8th grade. This is our lecture video over graphing. If you weren't at school on Tuesday, August 22nd, this is what we covered in our notes today, looking at how we take data that we have collected during our experiments and then taking that information and putting it into an appropriate graph. So here's what we're looking at. Typically, graphs the goal is to show comparisons between your independent and your dependent variables. So remember, the independent is the one that you control, and how you control that then determines what happens to the dependent variable. The cool thing about graphs is it lets us see an overall pattern, or hopefully a trend that occurred during the experiment. So we have three basic types of graphs that we use in science. We have a line graph, bar graph, and we have pie graph. Line graphs are the traditional way to go, especially when you have numbered data in both the independent and the dependent side. And the nice thing about a line graph is going to show how the independent variable and you manipulating it causes the dependent variable to change, usually over a period of time. Bar graphs, we will use these quite often. This allows us to compare categories of data, and you can have a single bar graph, you can have a double bar graph, you can have a triple bar graph, just like you would line graphs. You can have a double line graph, triple line graph. And then our pie graph is where we're showing the pie at 100%, and we can show percentages of different categories as a whole. It will always equal 100% though. So, how to make a graph. So, number one, you got to look at your variables. Your variables were determined in an earlier part of your experiment. And because of that, you're going to take the independent variable that you control and you're going to place it on the x-axis, also known as the horizontal axis. Then you're going to take your dependent variable that is dependent on the changes that you make in the independent, and it's always going to go on the y-axis or the vertical. One thing to always remember in graphs is you have to label your axes, and this would include any units that were used during the experiment for either the independent or the dependent variable. All right. Once that's been established, typically what you'll hear me tell you guys in class is that if you're looking at your graph, okay, we want to stretch that graph out as far as we can. So the easiest way to do that is to start with when you number your axes. So when you're looking at your data, find the largest possible number you have in each one of those, and then count the number of lines you have on your graph, and then take that number and divide it into that number from your data table. So for example, if my y-axis, my top piece of data is 160, I have 10 lines that I can play with. 160 divided by 10, going by 16s. So you can go by 2, 4, 6, 8. Never go by 1, 2, 5. Like, don't skip around. Always keep it consistent. Once you've numbered your axes, you can go ahead and plot, or you can put a title. On here, I have title next. You can go ahead and plot your data next. Otherwise, you want to title up at the top, where it's taking the dependent and independent variables and putting it together into a nice sentence. So I'll give you an example here. Change in pressure as the temperature rises, or the height in centimeters of fertilized treated tomato plants. If you're doing a pie graph, sometimes with bar graphs, and even with line graphs, sometimes you need a legend, similar to a map legend. This is where you're going to, if it's a double bar graph, you're going to show this color represents this data, this color represents the other data. Other reasons, lines and bars, they can be individually labeled. Sometimes that can make your graph look a little messy when you're doing that. All right, so this is something we're looking at this year. This is something new we're trying. It's called the Sultan method. Each letter of the word Sultan stands for a different part of your graph. So you have S for scale, so remembering that you've numbered evenly across your graph. U for units, putting all your units in the appropriate spots, specifically those axis labels. Having a label, L. Making your title, T, being accurate and neat when you plot your graph. So if you weren't in class today, this is where we stopped and kind of talked about some things, and then we began a station lab, an 8-station lab, where you and a partner walk around to the different stations and try to answer the questions. Some of the questions will be just to make a graph. Other questions will be about reading a graph. Both are useful skills, especially being able to read a graph. If you ever watch the news at night or you're scrolling through things on the internet, you'll see graphs all the time. So being able to read and understand what you're looking at in that graph is always helpful, especially after you leave school and you're looking at the real world. So, as always, if you guys have any questions, let me know, and I will see you next time.